figure out if a piecewise function, there's two different things that we need to look at with piecewise functions. It'll say, you know, is f of x, hang on, just stop. It won't let me write. So it'll say, is f of x continuous? That's one thing it's going to ask. And another thing it's going to ask is f of x differentiable? Yeah. Let me pull, I'm going to have to bring this up again because it decided to crash there for me. Which one out of the homework do you guys want to look at? We've got 22, 23, 24.
23, 24, 25, because I already did.
Okay. Let's look at 23 and then maybe we'll look at 25. Yeah.
Is he taking the test?
That is not how it works.
Okay.
He is taking the test, yes. Okay. Is f of x continuous? And then is f of x differentiable? Okay. So for continuous, what we do is we set the two pieces equal to each other. So one piece equal to the other piece of the original function. Okay, so this is like f of x. We're looking at f of x here. Okay. And then we plug in f of whatever number for x, and we see, do the pieces equal each other at that point? Okay. If we're looking at differentiable.
And then if they are, then it's continuous?
Yes. If they are equal, then they are continuous. Okay. So for this one, we say at, okay, so for number 23, it says at 0, we have x squared plus 1 when x is less than or equal to 0, and negative x squared plus 2 when x is greater than 0. So for this one, I would say, is it continuous? The first thing I would do is I'd plug in 0 to the function, set the pieces equal, and see if they equal each other. If they equal each other, check, they are continuous, right? Because that means one function touches the other function at x equals 0. Okay, so for this one, we would say f of 0 here would be 0 plus 1. And then, I shouldn't say x there, I should say 0. And then if I plug in 0 to this one, I get 0 plus 2.
So it's not.
So right, is this one continuous? No, because this piece doesn't equal this piece at 0. So automatically, is it differentiable? Nope. If it's not continuous, it doesn't matter. If this says it's not continuous, but this says it is differentiable, your algebra is lying to you, because remember how sometimes algebra tells us stuff that's not true? If it's not continuous, it's definitely not differentiable, no matter what. Okay? So let's look at one that is continuous. Okay. So number 24. Number 24, if I check, is it continuous? I plug 0 into the top and bottom pieces, right? And I see that these two pieces do in fact equal each other, right? The top piece and the bottom piece are at the same exact place when x equals 0, which means this touches this at x equals 0, right? Okay, so this one is continuous because the pieces equal each other at 0. Now the next question is it differentiable at that point? So we have to decide if there's a sharp turn. So what we do is we take the derivative and we see, are the derivatives equal to each other at that point? Because if they're not, if you think about if the derivative was 1 and then all of a sudden it's -1, that's a sharp turn on your function, right? Because if it's like going like this and then all of a sudden it like changes direction, that's going to be a sharp turn. So we're going to take the derivative of our piecewise function, and we have 2x and -2x. And this is still when x is less than or equal to 0, and this is still when x is greater than 0. So we have the derivatives now. So then we're going to do f prime of 0 on the top is 0, and f prime of 0 on the bottom is negative 0, exactly, is also 0. So are the derivatives equal to each other?
Yeah.
Yeah. So this one is differentiable.
That's all you have to do.
Yeah, you just have to take the derivative and then plug in whatever number they're asking about. If they were asking about 1, we would plug in 1. If they're asking about, I mean, this one is only where it, you know what I mean? Like if they're piecewise.
It doesn't have to. As long as they're both equal.
As long as you're right. Yeah, absolutely. If their outputs are the same, even if this was 100 and this was 100, they would be differentiable because they're both equal to each other, which means the derivatives are the exact same at that point. So let's look at 25 because those greatest integer functions make everyone a little bit crazy. Okay, so we're asking, is this continuous?
Would this be a calculator? Wait, we can't. Wait, do we?
This you should not. You would be more. It would be more work to do this.
Oh, really?
Yeah. Okay, so some of you are trying to like transform this thing in your brain right now, and you're trying to like figure out which way it goes, right? Don't worry about that. Okay. You could, in theory, try to imagine this graph, but most often we can't really imagine the graph very well. So let's use some algebra to figure it out. So first we're going to find, is it continuous at x equals 0? So we plug 0 into the function. Okay, so I have f of 0 equals 0 over 2 plus 1. So f of 0 is the greatest integer of 1, right? When I plug 0 into this, it is the same as the greatest integer of 1. So the question is the greatest integer of 1, is that continuous? Think about the point on the parent function. At 1, is the greatest integer function continuous? No, because there's a jump there, right? The greatest integer function looks like this. Right? So at 1, there's a jump. At the greatest integer of 1, it is not continuous. Therefore, this function is not continuous at 0. Does that make sense? It's hard to imagine because these greatest integer functions are like odd. So then we ask, if it's not continuous, it's obviously not differentiable, right?
Yep.
So then you're done.
Awesome.
So when you're doing that, you wouldn't keep it as 0 over 2 and then half 2 over 2?
Oh, I'm done with my own stuff.
Well, because 0 over 2 is just 0.
You go over some of the ones that like, they're the ones that.
Really, actually, hang on. On this one, I wanted to add something. If this was 1, if I said, is it continuous at x equals 1? Cool. Then we have a whole different ball game, right? 1/2 plus 1. This is the greatest integer of 1.5, or 3/2, right?
So it would be continuous.
Yes. Is it continuous at that point?
Because it's 1.5, so yeah.
Yeah, it's continuous right here, right? That would be at this point. It's continuous and differentiable at that point. Does that make sense? Okay. Which one, Casey?
The ones that are like, if r of 3 equals -2, like those ones, can you go over a couple more?
Yeah.